Okay. Thank you. Okay. Yeah, I will introduce myself shortly. Then I will talk about where we do come from regarding offline capabilities of browsers. After that, I want to point out what's different now with service workers. And after that, we dive in and I show you how to implement them. And yeah, after that, a little outlook on what's next. So, okay, who's talking here? Yeah, my name is Emanuel, and I'm a JavaScript developer here in Hamburg at Jimdo. We are offering like a website builder for the common people. I'm also on Twitter and GitHub. You can click the link if you are interested in that. I will post the slides after the talk. So, okay, where do we come from? You already have heard of it, I think. It's the app cache manifest. I called it the unloved child. Why did I do that? I mean, it has the declarative API that's easy to use on the first glance. You just set up a file like manifest.appcache and put in the path of the files you want to be cached. And after that, you register this file by putting this manifest attribute to the HTML element. And then you're good to go. That's it. The browser parses this file and puts all this stuff in the app cache. Sounds great, actually. But I have this quote by Jake Archibald. He wrote in an article, and he said, the application cache spec is like an onion. It has many, many layers, and as you peel through them, you'll be reduced to tears, which sounds harsh, actually. Yeah, why is that? Well, first of all, you actually have no control over what content is loaded with the application cache. So you can't be sure, or like another way, the application cache will always serve the cached content, even if there's a fresh version. And when the fresh version of a file is loaded from the network, then there's an update ready event. And the user has to reload the page to get the new version. You could do it yourself with navigator or location reload, but the problem is the user may already have interacted with the page, and then you can't just reload it and the user loses all the stuff he has done till this moment. So yeah, it's a little bit complicated to get new stuff served. The other thing is it is not enough to change files and provide them, but you have to change the manifest itself to signal to the application cache, hey, there are some changes, please have a look. Yeah, that's not that nice. And the other funny thing is the application cache interferes with the normal browser caching. So one might think it is a replacement for the browser cache, but this is not the case. So even if you manage to tell the application cache to load the new version, the browser still might say, well, the cache headers say it's valid for 5 years. I serve the old version. So to prevent this, you have to disable the normal caching for all files that you want to have on the application cache. This sucks. And it won't add you content during runtime. So you have a static file, the manifest file, and that's it. During runtime of your web app, there's no way to edit this file. So if you want to cache dynamic content requested during runtime, you have to do some hacking with localhost or browser databases. And finally, it doesn't require HTTPS. This sounds nice, but it leads to some security flaws, which I don't want to point out in detail, but you can Google it up. And yeah, all these points led Mozilla to even say, okay, that's enough. We removed the support for app cache. So soon you won't be able to use app cache in Firefox anymore. And maybe other browser vendors will follow. I don't know at the moment, but it is possible. So yeah, what is actually different to service workers then? Service worker is a new approach to caching. And first of all, they have no declarative API, but a programmatic API. So you write JavaScript and tell the browser which files to cache, and when to load or serve which contents. And this JavaScript is executed in a service worker thread during the runtime. And as the service worker is running, it acts like a proxy between your web application and the network. So you have full control over which requests go out. And so you can remove files and add files to the cache during the runtime. So you're not limited to static assets that you define before deploying your web app, but you can do this at the runtime. Yeah, and finally, as the service worker as a proxy, you have full control what to serve. There are several strategies to what serve when, if to hit the cache or to forward the request to the network. I will point out that later. Okay, so that's the theoretical background. Let's have a look at how to use them. There are some prerequisites. First, you need a secure connection. This is a learning from the app cache. Luckily, you don't need it on the local host, so you don't have to go through the hassle to install a certificate when you just want to fiddle around on your machine. Another thing is the support of the browsers. At the moment, only Firefox and Opera and Chrome support service workers on mobile and desktop browsers. But actually, this shouldn't be a problem. So service workers are regarded as a progressive enhancement, and your web app should work fine without them and get even better when the user's browser supports service workers. And finally, you should have a basic understanding of promises. So the API around service workers makes heavily use of them, and if you aren't familiar with promises, the code might look a little awkward. Okay, first of all, if you want to use service workers, you have to register them. And yeah, as I said, it's a progressive enhancement. So we first look at the navigator object if there's this property, service worker. And if this exists, the browser should support them, and we call the register method and register our service worker JS file. There's one thing to have in mind here. The location of this file defines the scope. So if you are used to put all your JavaScript in a JS subfolder, you might be tempted to do the same with the service worker file, but then your users won't have any caching because they won't go in the part of your web app or JS isn't part of your web app then for the user. So normally I think you want to put this in the root of your web app. There's also another way in the making. This isn't supported at the moment, but soon Chrome will support it, and Firefox signaled that they like this approach as well. And this is a declarative way to register the service worker with a link element. I just put it here for completeness. Yeah. Then when your service worker is finally registered, you can start managing your caches. And in the file, first of all, you need a version to control which files are cached and which old files to delete. So every time you edit this version, you have the opportunity to clean up your cache. I choose this number, but you can choose whatever string you want, like animal names or your favorite manga characters. They only have to change when you deploy a new state. Yeah, after that, I define an array with static assets like the index HTML and some CSS, some JavaScript, a nice image to make it more beautiful. And in the life cycle of the service worker, there's this installation process. And when this happens, the callback on the life cycle, on the install event is called. And the event object that is passed into it has this wait until method, which expects a promise. So the installation stops at this moment, and we have the opportunity to put our files into the cache. then the process goes on. So we open the cache and put our static files into it. By the way, this caches object, it's not only available in the service worker, but also in your main web application on the Windows object. So you could actually put contents into the cache from there if this does make sense in the situation. So yeah, we have put our contents into the cache, and the life cycle goes on. Next, it will be activated, and there again we have a call, an event to attach a callback to. And here we have again our event wait until method. And when the service worker is activated, we can clean the caches by getting all the keys from it and compare it to our current version. And if the cache doesn't match our current version, we just delete the stuff. And so everything is tidy, and we only have the latest content in our cache. Yeah, then finally, after the activation was successful, the service worker starts intercepting requests. And every time a request is made in our web app, this callback on the fetch event is called. And there we have a respond with method on our event object, which expects a promise, which then gets the contents that are served to the web app. And as I only have static assets in my cache at the moment, I immediately hit the cache. I don't have to go to the network because I know what is needed actually there, or no request planned. So I look up with the match method on the cache, and if there's a response, I return this, and if there is no file or no resource found, then the response is undefined, and then I forward the request to the network with the fetch function. And yeah, that's the basic usage of a service worker actually. What we've seen so far is like a usage that is quite similar to the app cache. We have static files defined before deployment of our web app, but it all happens with less pain and more control and hopefully more security with it. But what is more interesting with service workers is the caching of dynamic contents. So let's go on and look how to do this. There are basically two strategies when it comes to dynamic contents requested during the runtime. And the first one is network first. So you immediately forward the request to the network, and if it fails, you look up in the cache if you have an old version. And if it succeeds, you update the cache and you serve the response to the web app. Yeah, this code is there's a little bit more code about this approach. First of all, we have another version for the dynamic contents, so it doesn't interfere with our static assets. And we immediately forward the request to the network, and inside the callback in the then method, we open our cache with our current version and update the cache that matches the requested resource. And we have this funny thing here. We have to clone the response. So response objects, when they are used once, they are used up and gone. So you can't use a response for the cache and for returning it to the web app. We have to clone it. So the cache gets a clone, and the original one gets served to the web app. And finally, if this fails, we just look up in the cache if we have an old version to serve. What we see here is that we don't have to care about the online status of the user. There's this online property on the navigator object, which tells us if the user is online or not, but it isn't reliable. So if users are on shitty mobile connections, which leads to timeouts, or if they are on an airport and don't want to pay for the Wi-Fi, this property will tell us, yeah, the user is online. but actually they aren't. And with the service worker, or this approach to hit the network and then look up in the cache, we don't have to care about that. We just do our stuff, and finally something will come to the user. Yeah, when to use this approach? This is good for data that is updated very frequently, like soccer data at the weekend. So if you have a web app displaying soccer results, you might not want to show the user the results from the last weekend, but the current one. So you hit the network, and if that fails, yeah, you have to go with old data. And weather forecasts and stock market data are typical examples for this kind of contents. Yeah, the other approach would be to go cache first. So just look up in the cache and serve content really fast, but also do a request to look if there's a new version of this resource. The code is a little bit different. I have this unavailable function. I hope you can read this from behind, actually. Is this okay? No one said anything. That's good. Yeah, I have this unavailable function which returns a response with status of 5 or 3. This is our last resort, but hopefully we'll get contents before. So we immediately start hitting the cache and look for a resource that matches our request. And at the end you can see we return this. But we also do our request and again update the cache with the response if the request succeeds. And if the result from the cache is undefined, we will return our fetch promise. And if this fails as well, then yeah, we have to take our unavailable function that returns the 5 or 3. So we can either return old content fast or newer content from the network, or we fail gracefully with a 5 or 3. Yeah, and this is a good strategy for contents that aren't so updated so frequently, like blog posts and news articles. There you can serve fast, which is always good. Yeah, I kind of lied to you when I said there are basically 2 strategies. There are more. You might have contents where you don't want to serve old stuff and only hit the network and don't serve anything at all if the user is not online. You may also have contents where you only have to hit the cache. Remember the first example where I defined the static assets? I can be pretty sure that they are installed every time the web app is loaded and the service worker is installed. So actually I don't have to forward anything to the network. I just can hit the cache and serve really fast and boost the performance of my web app. And there's this fastest approach. On some devices, it maybe takes some time to read from disk if the device is old and has a slow disk I/O operation. And if you request a very small static asset, it might be faster to get it from the network. So you can start a race and make the request to the network and ask the cache. And whoever is faster is allowed to serve eventually. So this was it. Yeah, what's next? There are some service worker related specifications. For example, the push API, which enables you to annoy your users with push notifications. And what's nice about service workers is that they are running in a thread in the background. So even if the web app is not active, they can receive push notifications and you can handle them. Also, an interesting thing is the background sync. So the browser can store made requests, like post requests, if the user writes a message or something similar. And if the user then is offline, it's stored in the background and then synced when the user goes online. Yeah, and finally, geofencing. It's a good way to react to the case when the user enters or leaves a specific region. You could do this with geolocation, but here again we have this nice thing that the background, the service worker is running in the background. So the web app doesn't have to be active, and you can react to this nonetheless. Yeah, what's also next is I propose you learn more about service workers, and I have a list of resources which I can recommend, like a very good introduction to the topic on html5rocks.com. And if you are more into this topic, this offline cookbook by Jake Archibald, he's covering some more strategies to serve content. And there's this page with the URL serviceworky.rs. This is a collection of some very interesting recipes. Yeah, it goes really deep into the topic. Also nice is instant loading with service workers. It's a video from a talk at Google I/O. And it also covers tooling around service workers, like having a gulp task building a service worker, including all these static assets and fresh version strings. And he talks about the polymer component that handles service workers declaratively. I recommend this even if you don't want to use this component, but it's interesting to see how they solve problems coming up. Yeah, and if you want to see what the browser support is, have a look at this website. It's interesting to see how the things develop. Yeah, and finally, if you have your own web app boosted with service workers, you might need a service with HTTPS. I can recommend search.sh. I put my demos up there. You get a subdomain and can force HTTPS. Or you want to use CloudSec for your GitHub pages with a custom domain. Or finally, Let's Encrypt, so the latest solution for bringing HTTPS to the masses. Yeah, and that's finally it. Thanks for listening. If you have questions, then please ask me.